Hello, in this video we're going to be talking about the merge sort. Basically, what we're going to talk about is what the merge sort is, what it does, how it works, a visual representation, and some pseudocode, and finally the C++ program itself. Let's start off with what the merge sort is and does. Basically, the merge sort is known as the divide and conquer sort, where you divide the elements of your list or array into smaller parts so you can handle those, and then in the end, handle the array altogether. Usually this sort is created in a function that is recursive, so it can keep on doing it until all the items are sorted, and it's quite efficient, more efficient than linear sorts, like a bubble sort or a selection sort. So let's start off with a video.
Here we have 8 elements inside the list. These elements need to be sorted. What we're going to use is the merge sort. First, we're going to need to divide these elements into individuals. But before we do that, we'll need to divide them into smaller groups. Since we have 8 cards, we'll divide them by 2, into 2 groups of 4. Here we have one group of 4, here we have the other group of 4. We'll need to further divide these. We'll now have 4 groups of 2, and we'll even further divide these into 8 groups of 1. This works kind of like the bubble sort. We compare each item to its adjacent item. So let's start off with the 1 and the 8. We know that 1 is less than 8, so we'll place the 1 down first, and then we'll push down the 8 second. Now we know the 2 is less than 4, so we'll place the 2 down first, and we'll push the 4 down second. Remember, we're now creating 4 groups of 2. Now we have 5 and 3. We'll place the 3 down first, and we'll place the 5 down next. And then 7 and 10. We'll place down the 7 first, and we'll place the 10 down next. Now that we have 4 groups of 2, we can continue to make 2 groups of 4. To do this, we'll need to use the first item, or the remaining item, of the first group, and compare it to the first item, or the remaining item of the second group. So let's, for example, here we have a 1 and a 2. Since 1 is less than 2, we'll place down the 1 next. Now we compare the remaining item of the first group to the first item of the second group. We have an 8 and a 2. Since the 2 is less than 8, we'll push down the 2 next. Now we compare the 8 and the 4. Since the 4 is less than 8, we'll push down the 4 next, and what's left is 8. And we have 1 group of 4, sorted. Not completely yet, though. Now we have the 3 and the 7. 3 is less than 7, so we'll push down the 3 first. We continue on to the next item, 5 and 7. The 5 is less than 7, so we'll push down 5 first. And then since we know that these 2 are already ordered, we'll push these down as well. Now we have 2 groups of 4. What we now need to do is order them completely. So we start off with the first item of the first group, which happens to be 1. We compare 1 to the first item of the second group, which is 3. Since 1 is less than 3, we place the 1 down first. Now we compare the first item of the insorted group of the first group. We have a 2 and a 3. We push the 2 down first because 2 is less than 3. Now we have a 4 and a 3. Since 3 is less than 4, we push the 3 down. We have a 4 and a 5. Since 4 is less than 5, we push the 4 down. We have an 8 and a 5. Since 5 is less than 8, we push the 5 down. We have an 8 and a 7. Since 7 is less than 8, we push the 7 down. Let's make more space for the other cards. We have an 8 and a 10 remaining. Since 8 is less than 10, we push that down. And since all that's remaining is 10, we push that down as well. Now we have a completely sorted list of numbers.
Now that you've seen that video, let's start talking about code, and more specifically the pseudocode. So the merge sort we have here consists of 2 functions, merge sort and merge. Now this function here is going to start off the process, and what it has is a being an array, and n an integer which is equal to the length of the array. So here's our if statement. If n is equal to 1, return A. So what this means is if the array has only one item inside of it, we're just going to return the array because, you can't really store one item. Other than that, we create two arrays, L1 and L2. L1 is going to take the index 0 to half of n. So it's going to take the first half of the array A, and L2 is going to take the second half of the array. We're going to push these two arrays into the function merge sort, seen over here, and we're going to divide it again. We're going to keep on doing this until you get 1. What you're going to return, though, is merge L1 and L2. So, where'd my pen go? Here we go. Okay, so now we're going to run the function merge with the first half and the second half. So A would be L1 from here, and B will be L2 from here. We're going to also create another array called C. So while A and B have elements, let's just get rid of that. Here we go. So while A and B have elements, if A0 is greater than B0, add B0 to the end of C, remove B0 from B. Otherwise, add A0 to the end of C and remove A0 from A. So if you remember from that video, we're pretty much comparing the first two cards, or the first card of each group, to the other card. And what we're going to do is push them into the next array if it's greater or less, if it's less than. After this while loop is done, we have this while loop over here. While A has elements, add A0 to the end of C, remove A0 from A. And while B has elements, add B0 to the end of C and remove B0 from B. So this is going to keep on pushing it's going to keep on pushing the array values, what's left over, into the main, or into bigger groups. And it's going to return C. So when this returns C, what we're going to do is it's going to run through this again, except now instead of having, let's say we started off with 8 items. When we first ran this, it would divide it into 8 groups of 1. So once it goes through once, it's going to have 2 groups of 4, then it's going to have 4 groups of 2, and then finally it's going to have 1 group of 8, and the entire thing is going to be sorted. Now, let's check out the actual code. So here we have our main CPP file, C++ program, and in it we have 3 includes: the input-output stream, the F stream, and C time, which we'll talk about while we're using those. We have 2 functions, the main and merge. So we use the include F stream so we can read in files, so random.txt. This file contains 10,000 numbers from 1 to 1 million, and they're random. So we use this file and we use this line of code to read in each number. We also have an out file, which we're gonna use to output our sorted numbers into. We have a if statement where if it fails creating a file or reading a file, we get an error. Otherwise, all this works. This chunk of code here is used to read in the numbers. It's not as important. Here's where the merge sort starts, though. So our first for loop starts at 1 and increments by twice as much for increments the index by twice as much for each loop until the size of the array is reached. So I is going to equal to the size of array that's essentially that I is going to be equal to the size of the arrays that we need to merge. The second for loop here is going to increment twice as much as I, or twice as much as the merging array size. So it's going to be twice as much as this. Oh, sorry. And what this is going to be because we're merging 2 arrays. So this function here throws three arguments. We have the address of the first array, or we have the address of the first element of the first array. Our second argument is the length of the first array, and our third argument is the size of both arrays where the second array ends based on the pointer to the first array. So let's go up to our merge function. We have three integers here that we're initializing. These three integers are indices for merging. We have I is going to be, pardon me. So I is going to be the index for the first merging, or for the first array. J is going to be the index for the second array, so where the second array starts, and K is going to be the index for the merged array. So when we finally merge the arrays, we're going to use K. So this first while loop here is going to run through the elements of the two arrays to be merged. It's going to copy each next smallest element to the temporary array. The temporary array is an array we created inside the program itself, and it's going to be used as a dummy to sort the elements and to hold the elements while we're working with them. Our second array, when this while loop ends, we have copied elements from only one array to the temporary array. So next we have to copy, using these two while loops, we need to copy the remaining largest elements from the first or second array. This final for loop copies the array in from the temporary array to the main array we had, and this delete line gets rid of the temporary array. So let's try running this code. As you can see, it was very quick. It took about 20 milliseconds. And here we can open up the sorted text file. Starts off at 4,000 and ends at about 9 million. Or sorry, 900,000. Is that correct? Yeah, 9 billion. Okay. So as you can see, the program sorted the array perfectly. Awesome.